Okay, so Android is the brainchild of this guy named Andy Rubin. And you may remember a very cool, at least cool for the early 2000s, phone called the Sidekick. And Rubin's company called Danger produced the Sidekick. Now, Danger was eventually bought by Microsoft and, not surprisingly, summarily killed and never heard from again. So after that, Andy Rubin then started a company that began developing Android, which is a Linux-based mobile platform. And Google acquired Android and Andy Rubin along with it in 2005. Now, there are many types of devices that can run Android apps. We have phones, tablets, we have wearables, things like watches, TVs, cars, and more. And there are well over 1 billion Android devices in the wild right now. And there are thousands of individual models and dozens of different manufacturers. The Android operating system has gone through the steady evolution since it was publicly released in 2007. So each new major version of Android starts with a successive letter from the alphabet and is usually named after something sweet or a candy. So the latest version as of this recording is Nougat. The versions right before was called Marshmallow. The ones before that were Lollipop, Kit Kat, Jelly Bean, and Ice Cream Sandwich. There's also a version number that increases by 1 for each new release. Now, developers write code and build resources. Resources are things like images and sound files. And our build tools compile the code and then package all of that into a .apk file. And this is an Android package file. So the .apk is really just a zip file with everything you need for an app to run on Android. Now, the APK is what gets distributed when people are installing your app. So Android apps are typically installed from Google's Play Store. This is equivalent to Apple's App Store. But they can be downloaded and installed from other sources too. For example, I could send you an email with the .apk attachment, and as long as you can read the email on your phone, you can install the app on that phone. Now, perhaps the most exciting part of the Android development world is that there's a built-in channel for users to find and use your apps. Like I said, there are roughly 1 billion Android users out there, and they need apps. The Google Play Store allows the users to find your apps. And you can distribute your apps very easily. If your app will be free, there's actually not any fee at all to use the Play Store. If you would like to charge for your apps, and I highly recommend that you do, then there is a $25 fee that you have to pay to Google to get started. And then, of course, Google does take a cut from all of your sales after that. So they take 30%, but the rest is yours. Now, the App Store also creates kind of this store page for each of the apps, and it collects reviews and other information so that people can find out about your app. So here's a web page for this app that I'm going to use in this video to display the screen on my phone on my PC. And you can see there's information about the app. There's usually a video showing how it works. And there are reviews, so people can get a sense of what they thought of the app. And you can find all kinds of information. Now, the people who made this app, they didn't make this page. This is kind of generated automatically, or somewhat automatically, and then anyone visiting the Play Store can find out about your app. Now, almost all Android apps are written in Java. However, you can write some parts in C++ if you have some extreme performance requirements. Or you could write entire apps in C++, mostly if you're writing games using OpenGL or some kind of advanced 3D animations. Now, you can also use HTML and JavaScript to build an app and then have it wrapped up in this deployable package that can be distributed on the App Store. But for the most part, almost everyone writes their apps in plain old Java. Now, Android apps are not pure Java, however. So the first step in creating an app is, yes, to create Java bytecode. But then the bytecode is cross-compiled for this thing called the Android Runtime Virtual Machine, or ART, which is a different virtual machine than the standard JVM. So our Android apps are not pure Java applications, meaning that you can't natively run one on a PC. They can only be run on an Android device. Now, some people may be iPhone people, lifelong iPhone people, and they've never actually used an Android. For those people, let me give you just a brief walkthrough. Okay, so again, this is an app that's mirroring what's on my phone. And you can see at the bottom here, there are some buttons. So there's a triangle, a circle, and a square. And the circle will take you home. Okay, and the home screen is where you can place little icons for all the apps that you use. So there's a little bit of lag in the tool here, but on my phone it's running quite fast. If you want to see all the apps, you can click this button here. Okay, and these are just an alphabetical list of all the apps. We also have these little widgets. So a widget is like a semi-functional app, but you can put it on your home page and it's always there. So here's my calendar if I ever want to see what's on my calendar without opening the calendar app. I can use that little widget. This button here will list all of the open apps. So you can see I have several different apps open. This button here is the back button. So if I were to click here and open up a different page, I could hit the back button and it'll go right back to where we were before. Android has a nice settings system, so you can open up your settings and change things here. And then of course we have notifications. So usually the first thing I do when I pick up my phone is check out to see if there are any new notifications. Now this is all pretty standard stuff. Even if you're an iPhone user, it's really kind of all the same. Now there are some components that are available to help developers create their own Android apps. And I want to talk about those here. So the first thing we have is called an activity. So the activity is the basic building block of our UIs. We think of this as a window in a desktop app or a web page in a web app. Every single screen in an Android app is a distinct activity. It holds user interface elements like buttons and text boxes and drop-down lists. We call all of these UI elements widgets. Now we organize our widgets with these things called layout managers, which specify things like how many rows and how many columns there are in an activity, where the widgets are going to be placed on the screen, and so on. Now there are drag and drop GUI builder tools to create layouts, or you can manually create them by either editing XML or writing Java code. Android apps maintain resources. So a resource is a static, non-programmable element of your app. For example, any images you use in your app are resources. Most of the text that we put in our apps will be treated as a resource so that you can choose all of the resources in a particular language, like English or Spanish or French. Now at first this is going to seem like a pain, but it makes it very easy if you want to target your app to non-English speaking users. You write code that's tied to the activity to handle the user interface, like clicking a button, and then your code lives and dies with that activity. The next thing we have is called a service. And a service is a long-running part of an Android app. So they're programmed by you, the developer, without a specific user interface component. You can also schedule single tasks to execute in the future, or tasks that you want to have repeated every day or week or month. Then we have content providers. Content provider provides a way for other apps to access some data that your app is either creating or has acquired somehow. And you have some control over how that data is accessed. Then we have broadcast receivers. These listen for messages that have been broadcast by the system or from other apps in order to respond to them. For example, if your battery is running low, the system will send this broadcast message. And your app might change the way it behaves once it gets this. It might turn off a radio or turn the screen off, something like that. Other system events are when the screen turns off, switching from Wi-Fi to mobile, etc. Now, Android uses Linux to control the device. In one sense, you can think of Android as having a limited Linux API. So you can't do everything you can with a full version of Linux. And then the Android Software Developer Kit provides this collection of Java classes that lets you harness the power of that scaled back API. Every Android app runs as its own process. So a process is a running program. And one of the main jobs of the operating system is to isolate and protect the processes from each other. The operating system then provides a mechanism for processes to communicate with each other. So Android has this custom system of inter-process communication between apps. So here on the screen we see this IPC bus, that's for inter-process communication. And an intent encapsulates a request of some kind. It gets sent to an activity or a service, and the receiver reacts somehow to the event. So we create and pass events into the system. So for example, we might have this app here. Create an intent, send it on the bus to be received by this app over here. So you can choose to send an intent to an individual activity or to a single service. For example, one activity, maybe the screen of an app, may ask that another activity be started and pushed on the activity stack. And this is one of the fundamental flow constructs in an Android app. Or you can send an intent on the bus asking for any app that can satisfy some need. Basically, you can ask for some help. You can say, is there an app that can satisfy the request? You might prefer to use an existing one rather than write one yourself. So for example, let's say in your brand new app you want to somehow take and store photos. Now you could write your own user interface, your own activity, because you do have access to the camera from the Android SDK. But you also have the option of just broadcasting a take a photo intent. And then any app that's willing to do that work for you will start and provide the user interface and camera functionality for you. Now, if there are more than one app that can provide the functionality, the user gets prompted to choose which one they'd like to use. And they can even specify and say, I want to use this app always in the future. So this not only saves you the time and effort of writing and testing that functionality, but it makes your users feel like they already have familiarity with your app. And this consistency among apps is a really good thing. Okay, in the next video I'm going to show you how to create our very first very simple Android app.